Okay, Niantra, can you hear me?
Yes.
Okay, good. Let me see here. Yeah. So let me share with you how a binary file looks like. So that is a binary file that I tried to write. So that's how it looks like. Can you see my screen?
Yes.
Okay. So yeah, that's basically how it looks like. Okay. And if you try to open that, so if you try to open that in using a normal text editor in Windows, I think you will see something like this gibberish. Okay. So now let me go back here. The problem again with so when we are storing records, so typically we are storing it in ascending order. So the record have numbers, and then we would like to place it to place the records accordingly, especially with the sequential files. So it means that they are ordered somehow. So the problem is that when we try to insert a new record or even delete a new record, so that is an operation that is costly, like I told you previous time. So if this is our file and we want to add a new record here, so it means that if we want to insert the record somehow in the middle, so we will copy that part here first and then try to insert our new record and then copy the remaining portion here to here. And also if we want to delete, so we will do the same. We have to create a temporary file and then copy the new records inside it so that all the files is ordered on the record ID. So that is actually somehow an expensive operation to be done. I mean, expensive on the memory wise and the amount of time and effort that need to be executed from the computer. Okay.
Yes.
Okay. So let me look here. So if you want to write a sequential file to a binary.dat file, then you will have to use that method. So this is how we write a sequential file, because there is another way that we can use random access files. Okay. So again, here we open file for write, and then we put records, and then we use the put record command. Okay. So this is an array. This is an array of records, and then so array of objects it could be, and then you loop through until you reach the maximum number of records and insert it one by one. So this is a car file here, and then after you finish, you close the file. So what about if you want to open? So you use the command get record instead of put record. So you open the file for read, here you open the file for write, and the same goes here. So you restore whatever you read from the sequential file, the sequential binary file, you restore it inside the array of records. Is that clear?
Yes.
Okay. So let us have a look at VB code. So you see, I think so I think when you are trying to write a binary file, there is no easy way like the text file. So you use the easy way. You use the channel way when you wanted to write a text file. Okay, you didn't use the file stream and even the other writer, the stream writer, in that I taught you. So, but here there is no I think there is no other way. I searched in the other text files, other books, to find similar ways to yours, but no. So again, what I'm teaching you here is exactly according to the Cambridge. Okay.
Okay.
Okay. So again, first you need two types of variables. One is called forget about car file. I mean, this is a variable name that you can choose whatever you name it. But again, you need to create new file stream. Okay, and you pass it here, the file.
Sir, I can't hear you.
Okay, let me try to repeat again. So you create a variable. You create a variable, and from the type of file stream, and then you create a variable from type binary writer. This is when you try to write objects. So you're trying to write here sequentially to a binary file. Sequentially to binary file. You are writing, and you're writing the file mode create.
Okay.
Okay. So the way to write is that you use the variable that you defined from the binary writer, and you call the write method, and then you pass it whatever inside you want to write. Okay. So let us look first here, so that okay. Let me have a look here at the code. Let's see here. So I use our employee class. I created a function here that's called write sequential binary. Okay, I pass it a parameter called file name, and let us have a look. Where did I call it? So I call it here. So I pass it and a .dat file. So that is typically a binary file. Okay.
Okay.
And here I created a freelancer object. I initiated the object here, as you can see, and I pass it here. I pass the variable name here. Okay. And also I pass.
Could you repeat what freelancer does?
Okay, sure. So what is the last thing that you heard? And let me try to repeat from there.
No, I understood the write sequence, the file name, the binary file. I was just not clear about the freelancer.
Okay.
Over here in this page.
Okay. So the reason that I created that function, write sequence binary, I wanted to write the information, that is stored inside the part-time class. So inside the part-time class, we have many variables, right? Like the name, the staff number, the hourly rate, right? So yes, that will be stored. We initialize and store all this information inside the object freelancer, right? So I pass it here. Okay. And then let me go up here to the definition. So here I take an object. Let me clear that. So here I take an object and as an employee. Okay. And and then I initialize two things. You want to write a binary file, you need two things: binary writer and then file stream. So file stream, you will pass it the file name and the mode of operation. What mode of operation you want to do? Is it create or even read? So that's a different story.
Okay.
Or even append. Yes. Okay. So again, this is the file that we define here as a file stream. We created new, and then the file writer is a binary writer. It will take that file stream as an input here.
Okay.
Okay, and then you will start working with this file writer. So file writer dot write, and then you pass here object here is an employee. Employee have a name, have staff number, have a job. Okay. So and also it have an hourly rate. It have tools also I can put, but I just wanted to give you the concept in a simple form. We can work on improving that. So if I want to write an array of objects, I would pass here an array. Okay. And then I will make a for loop, and then I will loop inside, just adding a for loop here. I'm able to loop through all the objects inside the array, and then I will write all the contents here to the file, line by line. Okay? Does this make sense?
Yes.
Is it clear?
Yes, it's clear.
Okay, good. So okay, and then I created another function that read the sequence binary information and restore it to an object. Okay, so look at me here. I passed the file name, which is okay, it's fine, and we still use binary, but instead of binary writer, we use binary reader. File stream is the same, so we either use binary reader or binary writer, but file stream is always same with us. File stream takes the object name and take the file mode. Is it open? Is it append? Is it create? So that's how it works. Okay, and the binary reader here will take the file stream variable, and then we start reading.
Okay.
But this is slightly different from write. So when you read, you have to tell him you read what. This is not a text file. Text file you read line, or even you said line input, like in your case, right? But here you have to tell him exactly what you're going to read. Are you going to read a string? Are you going to read an integer, like in this case? Okay. Because he arranged the fields inside the record based on the size. So he need to really know the size that he is going to read from inside the date file or the binary file. Does this make sense to you? Okay. Sometimes it's not very clear, but okay. So again, here I read the name, the staff number, and the job. I left here out, just for simplicity, that I can take this 3 data and I can create an object and I can return the object from the function. But I didn't do that for simplicity only. Okay, so far, does this make sense?
Yes.
Okay, perfect. Okay, let me check. Should we tell you about yeah, let me tell you first. Yes, tell me.
Yeah, could you share me like the basic programs of this method? I think I might try learning this.
No,
I was thinking I could learn
no, again,
this method is.
So again,
sorry,
can you repeat again, because I didn't hear you very well. You want me to share what with you?
Okay. Like basic programs and like the key words and everything, like how to write programs with this method instead of the one I'm using right now. Could you share like with the stream reader and write?
Yes, definitely. So yeah, definitely. Wait, let me share. Give me a second, please. I will try to check if I have something open here.
With like the basics also, with like how to input, how to open the file.
Okay. Okay, let me share that. I think you can see my screen, right? So
Yes.
this is a book that I'm using. Okay.
Yeah, I have this as well, but I couldn't find like
see here
the key. I just found like a huge code. Okay.
So you want
Yes.
wait. So you mean you want simple instructions that tell you what exactly? Oh, simple codes. You mean simple example codes?
Yeah, simple.
Okay,
Yes.
I got you. Yeah. So I think maybe yes, I can share with you after here. Yes, I believe I got
Okay.
a file that. Yeah. So this is a simple file that have a lot of um, simple examples that you can go through, and the syllabus actually, I mean the index here, but again, yes, it is very close to this is very close to what to the syllabus, but not exactly 100% the same, but I think it should be fine. In general, it should be fine. Okay, so
Okay.
that is explaining everything in simple codes. Let me pass it to you after the class, and then the next class you tell me if you face any issues, then I can provide more
Okay.
simple codes. Okay, but I think that's very simple. From my opinion, that's very simple, and I think it will do the job for you.
Okay.
Okay, that's good.
Yes.
Okay, then we go. Let me go here. I would like to search hash. Okay, so we talk about hashing process before, right? Can you still remember
Yes.
what did we talk about hashing and how important is it?
Yes.
Okay,
So
so
there's a hash, but okay.
yeah, no,
Do you
I'm
want me
listening.
to explain it?
Yeah, yes,
Or
please, yes, please.
okay. So for each record that is stored, we calculate a hash value for its index, like where it is going to be stored. And if a hash has already been produced, collision occurs and it would be stored in the next index or in another overflow table.
Perfect answer. So you know that most of the time they will give you a hash function in the exam, and then they will ask you to do some calculation. Okay, so let me summarize. So the hashing process is contained of two things. You create a hashing function. Okay, the hashing function not necessarily using a modulus, but most of the time they use modulus most of the time. Okay, but they can provide you with a different function in the exam, so don't confuse. So we have a hashing function, and then this calculates the hashing code, and then we have collusion resolution. There is collusion resolution. I told you last time the method that they explained in details in the syllabus, but there is a method that they only mention as a how to say as a way of reducing collusion, but they didn't explain any details about it. So maybe you can find a question without asking for explanation, just the method of how to say avoiding collusion or solving the collusion when you see. So let me go through here. I forgot where I put that code. Yeah, let me see here. So yeah, the collusion resolution, actually there is three methods. We know one method in details, which is using the neighboring slot. Okay, which is we go to the next index in the array that we want to store our hashing code. So, but there is two methods, another two methods. Is called one called chaining and one called using overflow areas. And nothing more is required from you other than knowing that there is two methods. There is three methods in general. This one you're using in details, and we know how it works, and we study it in details. But these two other methods, we don't do anything about them. We just know that they exist, and that's it. There could be a question that comes out, so we're able to answer it. So the chaining, it creates a linked list for collusions with a start pointer at the hashed address. So if we have a hash address, so he link a linked list out of that, and he stored the hash codes that have similar place at the if they have a place here like that, and then we know that two records have a hash code that need to be stored at that specific index in the array. So he created a linked list that is pointing to this place, and then the linked list will have links to the records that need to be stored there. So he will not search for another places to store. He would just make a linked list here. And then when we're using the overflow areas, so all the collusions are stored in a separate overflow area, knowing as a closed hashing, and that's it. What you need to know. There is nothing else, and there is no more information about it here. Okay.
Okay.
So chaining methods, overflow areas, and neighboring slots. That's what we are using, and sometimes they call it open hashing. So again, let me go through. So previously we didn't use. Did you say something?
No, sir.
Okay. So okay, I didn't share with you anything about the hashing function in VB. That is not even mentioned inside the syllabus, but actually it comes in the exam. So that is so that's why I would share with you that code after in the after the session. So that is a function that he creates to be able to create a hashing code out of that. So what he will use again, the function is a pseudocode. He use it this way. He only have one parameter, and do you still remember n refers to what? So, I'm listening.
No, I can't remember.
Okay, so we have an array from 0 to 10, for example, and n is the size of the array. So we want to store our records here, okay? And then n is, so if you have an array of 10, then you pass here n equal 10, okay? But again, you don't, I mean, so this is a pseudocode, and typically in the pseudocode, you don't really run the pseudocode and you expect an output from it. Yes, you write it, but you don't have a compiler for it, and then there is no output. You just write it on a paper, okay? So that's why, most probably, that's why he never, again, this is mentioned in the syllabus the way it is now, and then that's why he never pass it as a parameter here. But when we write in DB and we expect to run that, so now, no, we have to write to provide the maximum position in the of the array that we're trying to create a hash code for it. So this is hash function. As we said, we pass a key value, okay, and we pass it the maximum position, and then we can use whatever. This is the same method. So sometimes they use -1. Sometimes they use a different method. Sometimes you didn't use modulus. But again, you just need to know this method and to know that, okay, it provides hash code. And if we have a hash code let me share with you what again. So, okay, insert hash. Let me share with you how we call the hash function. Let me clear that here. Okay. So if you can still remember, this is the hash function. Let me see, hash function that we just now a while ago we saw it. So you're passing here the record key, and this is, so you have a hash table which is an array. Basically, it's an array. So this is array length -1. So if you have an array of 10, so actually you have the length is actually 11, because it's from
11,
0
yes.
to is from
10.
0 to 10, right? So it's 11 positions.
Yes.
Okay, so that's why he passed hash table length -1, and then he passed here the record key. When he tried to insert the hash, can you still remember? We talked also last time about, let me see. So that is basically the array that he tried to calculate the hash for. So he passed the key, and those are the IDs or the keys that he would like to store inside the array. Each one, we call it a record key. He will pass this key, this number, here to the function, and we will get something out here. This something out, because we're using modulus, so it will be always a number from 0 to 9. Okay, so
Okay.
when I took these numbers and I run it in a real VB function, it get me out these values. The modulus loop, it get me out 6, and also I think it's this one get me 6, I believe, if I'm not mistaken, and then another one, it get me 6. So it means that two records, two different keys will be trying to store their value inside here. And then we said, if we find that this place is not empty, so we will try to search the next and insert that, right? So what if the
Yes.
what if the next is not empty? What we will do? We will increment the index and try to search here. If it is empty, we will insert it. So what if we reach it here? If we reach it here and we find also that this place is not empty, so we
have to go back to 0.
0, exactly. So if you understand that, so then we are able to go through the code here without an issue. So I repeated that because that is actually how the code here works. So the code here is saying we pass the record key here. We get the hash function. We get the index. We call the hash function. We get the index where we want to store our records. Okay. We will insert our hash, and then let me see here. So that is something extra. I just normally I always use right line, and I put things that can help me to know if what I am writing, the code I'm writing, is actually working correct or not. Okay, so now look here. He will make a while loop. Okay, so while hash table. So this is a hash table. Okay, while hash table is index not equal 0. So do you know what that means?
When it's not empty.
Yes, when it is not empty, so we have to keep incrementing index +1. So this is the index that we get from the hash function, okay? But if it is not empty, then we have to increment. And then we make an if statement to cater for the condition that we reach the end of the array. So if index bigger than hash table length -1, it means that we already reached the end of the array. Sorry, we have to close, and then we open again.
Okay.